Hi everyone, and welcome to part 2 of lesson 8.5, Law of Sines and Law of Cosines. In this video, we're going to be focusing on the law of cosines. Again, this is a law that can be used on any type of triangle. It does not need to be a right triangle. And by the way, both of these laws could be used on right triangles, but it's actually much more complicated to use them. You should stick with using the normal sine, cosine, or tangent ratios for right triangles. These ones are pretty much used on any triangle that's not right. Okay, so the formula you'll see here, there are actually 3 different formulas that are usually listed. And just like with the law of sines, where I say, okay, we don't need that third ratio because, well, A, B, and C could be anywhere. Well, the same thing is true here. Okay, A, B, and C could be anywhere. But the important thing with this formula is that the side A has to be across from the angle that we're interested in. So if we know angle A, then side A belongs over here on the equal part. If we are solving for angle A, then side A has to be over here on the equal part. Basically, we're solving for either side A here, or we're solving for angle A over here. Okay, now in this formula, you'll notice it almost looks like the Pythagorean theorem. A squared equals B squared plus C squared. But notice we have this minus sign here, so it's minus 2 times these 2 sides, BC, and then cosine of our angle measure. So the more you use it and the more you try and make those connections, that it's like the Pythagorean theorem where you're squaring the sides, A squared equals B squared plus C squared. And then it's minus 2 times these 2 sides, 2 times them, okay? And then the cosine of angle A. The more you practice that, the more you'll remember it. And trust me, these 2 formulas are really, really important, because when you get into later math classes, we're going to be using sine, cosine, tangent, and all of these laws again. So I suggest that you learn it well now. Now in the triangle, notice angle A and side A have to be across from each other. And you're solving for one of those. So we would use this when we know at least 2 side measurements in our triangle. So we can have side, angle, side, where you have the 2 sides and you know the angle in between them, and you're trying to solve for this other side. Or if you know all 3 sides, you can solve for any angle measure you want. Okay, so let's take a look at some examples of this, and you'll see how to work this formula. In example 3, they wanted us to find each measure, and they want us to round the lengths to the nearest tenth and angle measures to the nearest degree. So in this triangle, they want us to find the length of BC, which is over here. Now notice we know 2 sides and the angle in between, and that angle is across from the side that we want to know. So this is set up perfectly to use the law of cosines. So try and put these into the formula in the correct spot, and then press play to see if you're right. So what I did is I said that BC squared needs to equal AB squared plus AC squared minus 2 times AB times AC times the cosine of angle A. And you'll see that I put in all of the measurements here. So BC squared equals 14 squared plus 9 squared minus 2 times 14 times 9 times the cosine of 62 degrees. Now you'll notice that these are all numbers over here. So what I can do to finish solving this is just type all of this into my calculator and hit enter. But remember, that's going to equal BC squared. So at the very end, I just need to do a square root. So try and do that and then press play to see if you're right. So when I entered all of this into my calculator and hit enter, I got 158.6932. And I believe it went on from there. But then I needed to do the square root of this. Now, just a tip with your calculator, when you want to do the square root of the answer that you just got, what you can do is hit second square root, and then if you hit second and enter, it will take the previous answer that it gave and import it right into your square root. So you don't have to worry about copying things wrong. So you hit second square root and then second enter, and it will get that back in there for you. And I got approximately 12.6. And this is rounded to the 10th place. So let's take a look at another example. In this one, we're going to need to solve for an angle. In this example, they want us to solve for angle R, which is right here. Okay, so think about how the 4, the 7, and the 9 need to be placed so that angle R will be in the formula. See if you can do that and then press play to see if you're right. So I noticed that angle R is across from the 9. So the 9 has to be alone. So I have 9 squared equals 4 squared plus 7 squared minus 2 times 4 times 7 times the cosine of angle R. Now you'll also notice that I can't just type this into my calculator this time. So what I would recommend doing is doing this in a few smaller steps. Do the squaring and multiply 2 times 4 times 7. So basically deal with all of the red numbers here. Now you cannot do 4 squared plus 7 squared minus 2 times 4 times 7. This 2 times 4 times 7 cannot be combined with these because it's attached to the cosine of R, and that makes them not like terms. So what you're going to have to do is subtract this to this side, subtract this to this side, and then divide by this number. So why don't you see if you can do that and try and find out what angle R is, and then press play to see if you're right. So what I did is I squared my numbers. I added the 4 squared and the 7 squared because those actually can be added. They're just plain numbers. Then I subtracted that to the other side. And finally, I divided by negative 56. So I ended up with the cosine of R is negative 16 over 56. Now, to find out the angle measure, I need to use the inverse cosine. Remember in our lesson about inverse functions, when you want to find an angle measure, you do the inverse. So I did the inverse cosine of negative 16 over 56 is approximately 107 degrees. And that just all went into my calculator, and I rounded to the nearest whole number. So you have a check it out question coming up next. This is the last one we're going to do in this lesson. Check it out number 3 wants you to use the law of cosines to find each measure in these triangles, round the lengths to the nearest tenth and the angle measures to the nearest degree. Now again, it's very, very, very important that you show all your work with this because it's so easy to make a calculation error or accidentally do the order of operations wrong. So please show all your work. Don't forget to submit your check it out questions and let me know if you have any questions.